Hello guys, so I'm back with another chapter which is in the second PU syllabus for midterm, and this is a compilation of all the important questions which are surely going to be asked in the question paper. So just try to spend the time uh, of studying the questions which are important first, then go to the questions, because the thing which are being asked since years never stops. Okay, and they're literally very important because they form the base. So let's get started. Already have wasted 37 seconds. So first, standard hydrogen electrode, we are gonna know about that. So it is a primary reference electrode because its SRP value is assumed as 0 volt. The standard hydrogen electrode consists of platinum foil. The standard hydrogen electrode consists of a platinum foil, as you can see here, coated with coated with finely divided platinum. The foil is connected with the platinum wire with mercury. As you can see, it is a platinum wire, platinum foil, um, which is coated with finely divided platinum, and it is connected again with platinum wire with to a mercury. Okay, connected to mercury, a copper wire, this is the copper wire connected from mercury for external circuit. The platinum foil is dipped in 1 molar HCl acid solution as shown in the figure. Just remember this, you'll get, if you learn to draw this and labeling all these labelings, then it is easy to write that I wrote over here. So it's like that. Now talking about working, so pass pure and dry hydrogen. Over here we are going to pass pure hydrogen, which is dry, under 1 bar pressure, continuously at 1 bar pressure from inlet. The hydrogen gas gets absorbed on the surface of the platinum foil. The adsorbed hydrogen gas is in contact with H plus ions of 1 molar HCl solution. So when we pass hydrogen gas from here, the hydrogen gas gets adsorbed on the platinum foil, and it is in contact with the platinum foil, and also is in contact with H plus ions of 1 molar HCl acid. Now the electrode reaction is H plus, which is aqueous, plus there are electrons to form half H2, which will cancel H. Okay, this is electrode reaction. Okay, the symbolic notation of SHE, I didn't write here, I'll write platinum solid, H2 gas, and H plus aqueous. Okay, I'm sorry. Symbolic notation is this: the SHE potential is 0. The SHE potential is 0. Now the next question is what are the factors on which conductivity of electric conductance depends on? It depends on nature of electrolyte, temperature, nature of solvent and its viscosity, concentration of ions, and size of ions and their solvation. So nature, temperature, nature of electrolyte, nature of solvent, and its viscosity, temperature, concentration of ions, size of ions, and their solvation. What is conductance? It is the property of a material that allows the movement of electric current. It's easy, like it is a material. Just imagine this is a material, and this material has a property which allows electric current to pass through it. Okay, which allow the movement of electric current, and it is reciprocal of resistance resists the flow of electric current. So the SI unit is ohm inverse or mho. Ohm inverse is also called as mho. Now what is specific conductance or conductivity? It is the conductance of electrolytic solution placed between two electrodes of length 1 meter apart, and area of cross section is 1 meter square. Specific conductance or conductivity: the conductance of electrolytic solution the conductance of electrolytic solution placed between two electrodes uh, with a separation of 1 meter and area of cross section is 1 meter square. It is electrical conductivity and its SI unit is Siemens meter inverse. What is it? It is Siemens meter inverse. What is Kohlrausch law? The Kohlrausch law states that molar conductivity of an electrolyte at infinite dilution is equal to sum of the ionic conductances of respective cations and anions in electrolyte. It states that molar conductivity of an electrolyte which is at infinite dilution, full ज़्यादा पानी डाला हुआ है, वो एक मोलर कंडक्टेंस जिसमें बहुत ज़्यादा पानी डाल दिया है, इट्स ऑलमोस्ट लाइक नो वे इट्स गोना कंडक्ट इलेक्ट्रिसिटी, वो होगा it will be equal to the sum of the ionic conductances of respective cation and anions of electrolyte. Example, lambda naught of sodium plus lambda naught of chlorine. These are limiting molar conductivities of sodium and chlorine ions respectively. So as I said, it will be equal to sum of molar ionic conductances of respective cation and anion. Faraday's first law, really important, you guys. It states that the amount of substance deposited or liberated at any electrode during electrolysis by a current is directly proportional to the quantity of electricity passed through the electrolyte. Okay, there is the amount of substance which is deposited or liberated. I'm repeating. I hope you understand. If you didn't, just re-watch it because it's gonna be waste of time if you understood it. So work done is the mass of substance which is deposited or liberated is directly proportional to the charge to the current which is passed, the electricity which is passed through the electrolyte. Q is quantity of electricity passed. Q is equal to IT. We know that. W is directly proportional to IT, and when we remove this proportionality sign, we will get Z, and Z is electrochemical equivalent electrochemical equivalent of the material. This is important, you guys. Next is Faraday's second law. It states that when same amount of electricity is passed through different electrolytic solutions, the masses of substances deposited or liberated at the electrodes is directly proportional to their equivalent masses. W1 upon W2 is equal to E1 upon E2. Okay, next. What is primary cell or primary battery? The batteries which cannot be recharged or reused are called as secondary batteries. Primary batteries. But secondary batteries can, just remove this, for secondary batteries can be recharged and reused. What are fuel cells? The cells produce electrical energy for the combustion of fuels like this are fuel cells. So these are fuels which produce electric energy when they undergo combustion of fuels like hydrogen, methane and methanol. Fuel cells. Corrosion and its prevention, also an important and boring question being asked since 9th standard, I would say. The process of deterioration of a metal, like you are in a higher level, like you're in second PUC. If you say rusting, oxidation, it's like it's good, but just use the word deterioration, it's good. As a result of its reaction with air or water in its surrounding. Example, rusting of iron. Okay, rusting of iron. Prevention is painting, galvanization, applying oil or grease, electroplating. Galvanization is nothing but coating iron with zinc. What is molar conductance? It is the measure of how well a solution conducts electricity due to the ions present from 1 mole of an electrolyte dissolved in specific volume of solution. How well a solution conducts electricity due to ions present from 1 mole of an electrolyte dissolved in specific volume. This is also important, you guys, being asked in so many years, so why not go through it? hydrogen oxygen fuel cell. In hydrogen oxygen fuel cell, electrical energy is produced by the combustion of hydrogen. As you know, fuel cells produce electrical energy by the combustion of fuels. The same way, hydrogen oxygen fuel cell, the electrical energy is produced by combustion of hydrogen as fuel, not methane or methanol like that. So the construction, in this cell, hydrogen and oxygen are bubbled through a pair of carbon electrode into concentrated sodium hydroxide aqueous or concentrated sodium hydroxide or concentrated potassium hydroxide. Both are aqueous. Catalysts like finely divided platinum or palladium metals are incorporated to the electrodes for increasing rate of electrode reactions. So the construction is that hydrogen and oxygen are bubbled through a pair of carbon electrodes are bubbled into concentrated sodium hydroxide or concentrated KOH. Catalyst is these are catalysts which are incorporated to the electrodes for increasing. What do? They increase the rate of electrode reaction. Hydrogen is passed into anode compartment where it is oxidized, and oxygen is passed into cathode compartment where it is reduced. So hydrogen कहाँ पे भेजा गया है? एनोड पे, एंड ऑक्सीजन कैथोड पे. एंड हाइड्रोजन एनोड पे जाके क्या होगा? वहाँ पे ऑक्सीडाइज होगा और ऑक्सीजन कैथोड पे भेजा जाता है और वहाँ पे उसका रिडक्शन होगा. The electrode reactions are as shown below. Anode or cathode में क्या? We passed hydrogen at anode, right? So this is the reaction and here this is the reaction. The overall cell reaction is 2H2 plus O2 gives 2H2O. The cell runs continuously as long as the reactants are supplied. What are the reactants? Hydrogen and oxygen. जब तक हाइड्रोजन ऑक्सीजन नहीं देंगे तब तक वो नहीं होगा. Fuel cells produce electricity with an efficiency of 70%, about 70% compared to the thermal plants whose efficiency is about 40%. Thermal plants are 40% and fuel cells produce electricity with an efficiency of 70%. There's a lot of difference, guys. And this is the mukhda of the cell we are talking about. Yeah. Anode जहाँ पे हाइड्रोजन डालते हैं, कैथोड जहाँ पे ऑक्सीजन, and this is aqueous electrolyte and water nuclear. So now there is a question which asks us to write about the SI units. Resistance का ohm, specific conductance का Siemens meter inverse, molar conductance का Siemens meter square per mole. N doesn't mean number of unpaired electron. N means number of, yeah, it means, but not here. Okay. Equivalent conductance Siemens meter square, gram equivalence inverse resistivity Siemens. Ohm meter. Next is the question. Specific conductance decreases with dilution and molar conductance increases with dilution. Specific conductance decreases with dilution. See, D. Molar conductance increases with dilution. स्पेसिफिक कंडक्टेंस और कंडक्टिविटी जितना डाइल्यूट करेंगे उतना कॉन्सेंट्रेशन ऑफ आयन कम होगा, तो ऑब्वियसली देयर विल बी डिक्रीज इन specific conductance, whereas molar conductance increases with dilution. What is molar conductivity? The molar conductivity of an electrolytic solution, of an electrolyte solution at infinite dilution, meaning the concentration of electrolyte is essentially इतना पानी डाल के डाइल्यूट कर दें कि concentration of solution एकदम ज़ीरो हो जाएगा. On infinite dilution, half cell reaction, net cell reaction, Nernst reaction, 3 are also like bhai behan and really important also. हाफ सेल रिएक्शन में ऑक्सीडेशन रिडक्शन, एनोड पे ऑक्सीडेशन होता है और कैथोड पे रिडक्शन होता है. यहाँ पे जिंक जो सॉलिड ऑक्सीडेशन मीन्स लाइक प्लस हो जाता है, ऑक्सीडेशन नंबर कम होता है, तो दिस इज जिंक +2 and 2 electrons are removed, and copper यहाँ पे कैथोड पे रिडक्शन हो रहा है, which means addition of electrons of Cu solid. Net cell reaction, the net reaction is the sum of half cell reaction with the electrons cancelling out. Okay, look here, the electrons get cancelled out here, so zinc solid plus copper 2 plus aqueous. So basically net cell reaction is nothing but the sum of half cell reaction, just you're gonna do this zinc plus this. Next is Nernst reaction. Nernst equation. This equation relates the cell potential to the standard cell potential and the concentrations of the reactants and products. For the Daniell cell, the equation is E cell is equal to E naught cell minus 0.0591 upon N log zinc 2 plus upon copper 2 plus. E cell potential E naught cell is the standard cell potential, N is number of moles. The next question is anode and cathode equations for ion corrosion in the atmosphere. ATM means atmosphere. Anodic, cathodic. Ion, what the hell? Okay. Anodic, Fe, solid. Anode means removal. एनोड पे ऑक्सीडेशन होता है, सो रिमूवल ऑफ इलेक्ट्रॉन्स Fe2 प्लस O2. कैथोड पे ऑक्सीडेशन विच मीन्स cathode पे reduction, addition of electrons, like that. Oxygen plus water, let's see, you'll get this. And SHE has reduction half cell reaction of 2H plus 2 electron gives H2. Symbolic representation is this, and standard electron Russian, you know, it's 0 volt. It's a show off. SHE has reduction half cell reaction, symbolic representation, standard. Dry cell. What is dry cell? You know what is dry cell? Dry cell is a dry cell. Anode may oxidation, cathode by reduction as usual. So zinc turns into zinc 2 plus 2 MnO2 NH4 plus to give this. Lead storage battery, lead plus sulfate to give lead sulfate. Lead oxide, sulfate, all these, in these you'll get lead sulfate. Fuel cell, anode पे oxidation, cathode पे reduction, 2H2 से 4H plus, oxygen 4H plus say 2H2, and that's it. That's it for the video, guys, and thank you so much for watching, and stay tuned for the next chapter, which is going to be haloalkanes and haloarenes again for second PUC important questions. Thank you.